Chapter 10, Section 2, in the 7th grade note-taking guide, is entitled Volumes of Prisms and Cylinders. So start off here, this is our first introduction in the 7th grade curriculum to volume. What is volume? Volume is how much something can hold or how much space an object takes up in a given location on Earth, whatever you want me to say. Usually when we think of volume, we think of a science class. We picture ourselves with that graduated cylinder, and we're pouring liquid into that graduated cylinder, and whatever mark that liquid comes up to is the volume of the graduated cylinder, or how much space that liquid is taking up. Right? That's what volume is. It's how much space that item takes up. When we're talking about volume here, we want to know also that units are important here when we write our final answer. Volume answers always pop up as units cubed. So when we write our answer, we're going to write inches cubed or feet cubed or centimeters cubed or whatever on the end of our numerical value response. All right, so what is volume properly? It's the number of cubic units needed to fill a given space. In this particular section, they're only going to focus on prisms and cylinders. In the next section, they're going to focus on some other shapes, namely cones and pyramids. So as we look at number 1 here, they're asking me to find the volume of the prism that you see on the screen there. Now, one of the first things they give us that's very important here is the formula. Formula there says B times H. To find the volume of a prism, you take the area of the base and multiply it by the height. Now, the thing is here, they can't be more specific than that because the base of a prism can really be any shape other than a circle. It could be a triangle, it could be 4 sides, which leaves it open to the realm of possibilities, square, rectangle. It could be 5 sides, it could be 6 sides, it could be 7, 8, how many ever sides they want. So they can't really be too specific, so that's why they're saying B, the area of the base. We'll have to use whatever shapes formula that would be then, and multiply that by the height of the entire figure. So here, as we look at the shape, the way this is laid out here, all right, the base is going to be this piece that's either on the left or right side here, however you want to think about it here. So the base here is going to be this 4x4 piece here. So the base there is going to measure 16. All right, now we're going to take that base and multiply it by the height. The height is the only other number they've given us in the illustration there. And since this one is laying down, that's going to be the 12 there. So this is going to be the same as 16 times 12. And 16 times 12 is going to change into 192. And so the volume of the box is 192 cubic feet. The reason I changed this a little bit is because in that particular type of prism, rectangular, it's really not such a big deal because you're just going to multiply the 3 numbers together. But when I start giving you other types of prisms, triangular prisms where the bases are triangles, or pentagons where the bases are pentagons, we always identify the bases as the thing there's only 2 of. All right, and the thing that there's only 2 of in that shape are those squares that are as pictured on the left and the right side. Those rectangles that we see up in the front that would roll around to the back and then towards the bottom, there's 4 of those. Generally, we would not consider those to be the bases. We would consider the bases to be whatever there is just 2 of. All right, think of a cereal box. If I were to stand the cereal box up, all right, what would the base be? Well, it would be standing up the tall way there. So generally, we consider that to be the bases, whatever there's 2 of. So even though it's laying down and we present with the height of 12, which is not customarily how you would present 12, you'll see as we get into other questions, the base we're going to always identify as simply whatever there is just 2 of. All right, so now as we come down here, now they're going with a cylinder. Now the reason these 2 shapes are together in this section is because they actually use the exact same formula for finding the volume. The difference is here I can be specific to the base because the base here is guaranteed to be a circle. And since the base is guaranteed to be a circle, I have to do pi r squared for the area of the base. It's not a guessing game anymore. I'm absolutely 100% sure it's going to be pi r squared. Pi r squared is going to get multiplied by the height, how tall that whole guy is, and again, just like the other formula, area of the base times the height. So, I need to identify pi, r, and h to find the volume of the can of tuna. Pi is, of course, 3.14 in our calculations. R is the radius of the circular base, which is marked here at 5. And h is the height, how tall the can of tuna is, and that's this 4.2 centimeters. So it's 3.14 times 5 squared times 4.2. Well, a little bit of order of operations is going to make me do this 5 squared first. That's going to change into 25. So this is 3.14 times 25 times 4.2. And when I multiply those three numbers together, 3.14, 25, and 4.2, the result is approximately 329.7. Remember, we've estimated 3.14 is pi, so we can never say this is an exact answer. But the volume of the tuna can is about 329.7 cubic centimeters. Again, units are always going to pop up units cubed here. So centimeters cubed makes good sense. Now, as we come down here to number 3 is a composite figure. We've dealt with composite shapes in 2D, and now here they are in 3D. All a composite figure is, it's an amalgamation of shapes. We're putting a bunch of shapes together and saying, this is one giant figure, find the volume of it. All right, so to find the volume here, we're going to find the volume of each piece and simply add those volumes together, and that will be the volume of my composite figure. Now, if we were finding surface area, we'd have to think a little bit here. And the reason we have to think about a little bit if we were finding surface area is when we're finding surface area, we're finding the area of all the pieces that were exposed. So if I was finding the surface area here, well, the bottom of this triangular prism is not exposed. It's not on the surface. So I would have to take that off. This piece that is the top of the rectangular prism that they're marking here is not fully exposed either. So we would have to take off that chunk that is not exposed. Luckily for us, though, we're finding the volume here of the house. How much I can fit in this kind of weird looking house. That's what I'm finding here is the volume, how much I can fill inside of it. So I don't have to worry about taking off pieces here because I can just fill it up and fill it up and fill it up. And once it's full, that's the volume. There's nothing I can take off because there's no odd pieces that are missing here. So find the volume of the rectangular prism, add it to the volume of the triangular prism. So as far as the rectangular prism goes, all right, you're going to take the area of the base. Well, the base is on the front here of the rectangular prism. As you can see, as we go around this way, you've got these 4 rectangles going around. So I would not generally consider those to be the bases. All right, the bases would be the front and the back here. All right, so that's going to be 4 times 6 here for the base, which is going to change into 24. And then I'm going to multiply that by the height. Well, if this is the base that I'm staring at, the height is actually laying down, so the height is 12. So I'm doing 24 times 12 there to find the volume of the rectangular prism, the bottom piece. That's 288. Then I got to go to the top piece and find the volume of the triangular prism to add that on. So if I'm looking at the triangular prism, again, base is the thing there's 2 of. That's the triangles in the front and back. Again, here's where it's really going to matter. It doesn't really matter so much in the rectangular prism. As you can see, they labeled it a little bit differently and came up with the same answer. But here, it matters. All right? The triangles here are the bases. So the formula there says take 1/2. You're saying, well, wait, where did 1/2 come from? 1/2 is how I find the area of a triangle. Multiply it by its base. So that's going to be this bottom piece here. And even though we don't have a label here, we can read down to see it's the same as this distance here, which is the same as this distance here, which is marked at 6, times its height, which is marked at 4. So we've got 1/2 of 6 times 4 to find the area of the base, the area of the triangular base. And we're going to multiply that by the height, how tall this is. Well, again, that means this one's laying down if I'm staring at the base. So this is 6 units tall. which is what you can see they've got right here. So we're going to multiply. That's the same as 3 times 4, which is 12. 12 times 6 changes into 72. And then I add these two guys together, and I get 360. So the volume of the composite figure is 360 cubic feet. All right, so let's go ahead and take a look at the concluding examples here. Number 1, find the volume of the prism to the nearest tenth. So find the area of the base and multiply that by the height. So the base here is going to be this bottom piece here we'll go with right now. This one almost looks like a perfect cube, so really not going to be a big deal. It's not quite a perfect cube, but again, as we saw with the rectangular prisms, it really doesn't matter anyway which one we actually call the base. We just know the base should really be the one there's two of. So we've got this 6.3 by 8 piece on the bottom. That's how I'm going to find the base. And then I'm going to multiply that by the height, how tall the shape is. Well, it also happens to be 6.3 tall. So I'm going to do 6.3 times 8 times 6.3. And when I multiply that together, I get 317.5 feet cubed. When we go down to the cylinder here in number 2, where they're asking me to find the volume, remember the formula changes a little bit, but only because it becomes circle specific, because the base has to be a circle. So instead of saying b times h, they're still using h, but they're multiplying it by pi r squared, which is, of course, how we find the area of a circle. Pi is, of course, 3.14. Multiply that by the radius squared. Well, the radius of the circle there is 7 squared, times the height, which is 3.8. This is a multiplication problem at this point. I'm going to multiply these three numbers together. 7 squared first by order of operations is going to change it to 49. 49 times the 3.14 times the 3.8 changes into 584.7. And that's going to be 584.7 meters cubed. The volume of the cylinder is 584.7 cubic meters.